Okay, this is an ideal gas law problem with changing conditions. All of these properties are together. Let's call them condition 1. These two properties we'll call condition 2. Now, again, it's important to keep these together. You could have called this 2 and this 1. The answer would have been the same as long as these values stay together. What the question's asking for is the volume of the new container. Now we start with the ideal gas law under changing conditions, and nothing's said about any moles of gas changing. So we assume that that's N1 is equal to N2, which means these cancel out. Again, we're trying to solve for the volume of the new container. So that would be V2. So we're going to solve this expression for V2. Again, when we have a situation where we're solving for a variable in the denominator, the best thing to do is to cross multiply because you won't mess yourself up so much. So we have P2 times V2 times T1 is going to equal P1 times V1 times T2. All right, so we've solved our equation for V2. Now we very carefully substitute in our variables, knowing that all of these pertain to condition 1 and these pertain to condition 2. Okay, now listen very carefully here. We see these units of pressure are millimeters of mercury. Now, we do not need to spend time converting between millimeters of mercury to atmospheres and then back again. These two units will cancel each other out. All right, when there's an ideal gas law problem that uses R, you have to make sure that pressure is in atmosphere, volume is in liters. If R is not used, all you have to do is use consistent units. So here, millimeters of mercury is going to cancel out with millimeters of mercury. However, you still must always use the Kelvin temperature scale. All right, so we check our units. We see we have units of volume, milliliters. We're done.